Sinulta Automation Builder. The Sinulta Automation Engine allows you to build custom logic using an extensive library of function blocks. The Sinulta trial version includes a number of automation tutorials and sample projects, demonstrating key features of the Automation Engine. Automation Engine is made up of two parts: Automation Builder and Automation Server. Automation Builder is your logic editor, and Automation Server is your logic executor. SCADA people can think of it as a soft PLC except with much more power. Please make sure that both Sinulta Trial Demo and Automation Basic Logic projects are running and highlighted in green on the project list. Double-click on the Automation Builder icon in the System Manager to start. Select the Sinulta Trial Demo project and click OK. Click OK to accept the default username and password. Modules. The tree view to the left shows a list of different types of modules. Expand the Periodic Modules branch and select the first module to see its content. Each module is a container of a list of function blocks that execute from the top to the bottom. Right-click in an empty area inside the module and select Module Trigger Configuration to see how it works. There are 7 types of modules available. Periodic modules are triggered based on their set time interval. As you can see, this module is set to run once an hour but could be changed to run as fast as 5 milliseconds. Scheduled modules are triggered based on a configured date and time from a calendar. Event-triggered modules are triggered instantly upon any specified event. This event could be as simple as value changing. In this example, this module will be triggered when the value of the specified tag goes from 0 to 1, also known as a rising edge. Startup modules run only once on startup. These modules are typically used for initialization of your automation parameters before executing other modules in your system. Subroutines allow you to share a common set of logic between all modules. Both subroutine and trigger event modules can be called from other modules, except you can pass variables to a subroutine at the time of calling them. For example, the Daily Report module calls the Calculate Averages subroutine when it is triggered. Business workflow modules are also trigger-based modules. However, they are triggered based on the incoming transactional requests from outside. For example, to view a file from a web page or a smartphone, the app can send a request to a business workflow module. The business workflow logic will process the incoming message, prepare the request file, and send the file back as a response to the app's request. Logic points are very similar to the event-triggered modules with only one major difference. Logic points are database objects and are managed by the Database Builder. While we can see and edit logic points from the Automation Builder, logic points can only be created or removed from the Database Builder. Logic points play an important role in creating abstract field mirrored devices as part of database classes and templates. Function blocks. Sinulta Automation Editor provides over 130 function blocks that are accessed from the Functions pane and can be dragged and dropped onto a module. Each function block is equipped with a help menu that can be accessed from its right-click menu. Function blocks have a certain level of error checking to detect any invalid input or output types. In addition, each module checks and validates its content before allowing you to publish your logic to the server. There are also a number of special function blocks. Database function blocks allow us to query any internal or external databases. The VB.NET and C# scripting function blocks allow users to build their own customized function blocks. Building logic. Here is how we can build logic to add the values of 3 system points. Right-click the Periodic Modules branch, select Add Module, and name it Simple Add. Let's set this module to run every 5 seconds. Open the module, then drag and drop an Add function block to this module. Let's set up a third input to the function block by right-clicking one of the input parameters and clicking Add Parameter. Name it C. From the System Objects pane, drag and drop 3 analog points to the input and 1 to the output. From the right-click menu, validate this module. Save and publish. Now, click on the Online/Offline icon to see it run. The system detects that you have made a change to the configuration, and it needs to publish this change to the online server before it can run it. Click on Publish, then click Yes to publish the configuration to the online server. Note that we updated the server without having to restart the system. Another way to publish the configuration changes is through the Save button. Let's switch back to the offline mode. Drag and drop another Add function block to the module, and add analog points to the input and output. Note that the module header and its icon in the tree view are changed to orange, indicating that the module is changed and needs to be validated and saved. Click on the Validate icon and then click Save. The system will then prompt you to publish this logic to the local server. Click Yes to overwrite the previous configuration. As you can see, this method of updating logic will require the automation server to restart. Click Yes to begin restarting the server. Opposite to publishing, we can use the Retrieve function to retrieve an online configuration to the offline side. We can also share the automation logic with other projects, using the import and export options. Offline and online mode. We are currently looking at this module in offline mode. Double-clicking on any one of the tags displays the tag definition dialog box. Click on the Offline/Online icon to go to the online mode. The header portion of this module shows how often the module is being executed and how long it took to execute the last run. By double-clicking on any one of the tags, we can change their values. From the right-click menu option, disable the first function block. Now change the value of its input point and note that the output is not being updated even though the module is set to run every 5 seconds. From the right-click menu, add a breakpoint on the second function block and note that the logic stopped on the next scan. Click on the Continue icon and see that the module gets executed once, then stops on its next scan. Enable the first function block and remove the breakpoint from the second function block. The module is back to normal and is updating every 5 seconds. Tutorial projects. Let's switch to the Basic Automation Logic tutorial project for the remainder of this video. From the System Manager, double-click on the Real-Time Viewer icon and connect to the Basic Automation tutorial project. The Introduction HMI screen shows how Real-Time Viewer and Automation Engine exchange data through the Event Engine. Each button in the header provides a set of screens going over the fundamentals of the Sinulta Automation Engine. From the Automation Editor, open the Sinulta Tutorial, Automation Logic Basic Project. Let's arrange the windows to see both the Real-Time Viewer and Automation Editor at the same time. In this project, the Automation Editor has a folder of event-triggered modules to demonstrate math functions. Open the ABS module and set it to online mode to see the values currently being used. From Real-Time Viewer, select the Math screen and change the input field for the absolute value, and watch how the automation function block updates its output, which then updates the output field in the Real-Time Viewer. Using the same concept, you can examine all available automation function blocks by going through all other screens in this project and other automation tutorial projects. Module performance. Each module runs as an independent thread. This means that if one of the modules gets stuck or takes longer to execute its logic, other modules will not be affected by it. As you can see from the System Manager, the automation server uses a relatively large number of threads due to the number of modules in this project. This means that computers with more cores will provide more power to Sinulta. In many cases, more cores and slower clock speeds result in a better performance than fewer faster cores. Automation points. Sinolta Automation provides 3 categories of points. Constant are read-only points that are accessible from any module. Local points are local to each module. Global points are shared across all modules. Please note that automation points are not counted towards the licensing point count, so feel free to use as many points that you need to build your automation logic. In addition to the automation points, the automation engine can directly read and write to the system points, designated with a letter S.